Good afternoon, ladies and gentlemen. So, going with a different camera angle today, we'll see how this goes. Hopefully it'll all turn out perfectly fine, and it'll all turn out right. Let me fix that camera out real quick. There we go. Alright, so welcome back. We are now today going to be in lesson 13 as I prepare you for your next assignment. Your next assignment is quite a bit longer than the last one that you were given. This one is question numbers 2 through 5. It is the problem set within lesson 13. So we're on page 135 in module 4. We are continuing to pick up and just go a little bit further and a little bit further and a little bit further with how we deal with these types of equations. So in doing that, we're going to take a look at what is given to us and what is expected from us. To do that, you're going to need obviously your pencil, obviously your book. You are also going to want to have a sheet of graph paper. So if you see graph paper, like little square boxes, and a straight edge. I have my notebook taking ruler, so I'm just going to use that. Okay. After we fill out this table, we do need to plot the points on this as a coordinate plane. So I'm going to take a second. I'm going to demonstrate what that should look like. If you have graph paper, fantastic. If you don't, it's not the end of the world. At the end of class, I'm going to show you, or rather at the end of this video, I'm going to show you some way you can do that online. Make your life a lot easier when you don't have graph paper to use. And then I also, of course, need you to know how to use graph paper when it is required, when you do have the opportunity. So we're going to take this equation. We're going to do what we did with the last video, with the last set of tutorial, is we're going to pick an x value, plug it into our equation, see what we get for our y value. Pretty simple, pretty straightforward. From there, we're going to plot the points on a coordinate plane, and then we're going to answer a question way down here at the bottom, which is, what is the shape of the graph that the linear equation takes? Okay? So, we're going to start back at the top, and we're going to find at least 10 solutions. So what that means is 10 different points, 10 different x values we are going to pick for this equation. We're going to plug that x value into our equation. We're going to find out what the y value is given to us after that. Okay? So we're going to plug in the value for x, see what our y value is, tally that over here, and then, like we did at the end of the last video, we're going to keep track of each one of these x's and y's as a ordered pair, or rather as an ordered pair. The reason for that is because we are going to plot these points on a coordinate plane. So we're going to need to have a set of coordinates. We're going to need to have a set of ordered pairs in order to put those points on the graph. So let's get started. As always, when you are required to pick x values, the easiest one to start with is always going to be 0. So that's going to be my first one here. Okay? I'm going to start with 0. So when I plug 0 into my equation, it's 3 times 0 plus y equals negative 8. Luckily for me, I have a positive y value, so I'm not going to have to take whatever the constant is on the other side and flip the sign like we had to do with the last couple of examples in the previous video. Here, 3 times 0 is obviously 0, plus y is equal to negative 8, which means that y is equal to negative 8. Pretty straightforward. The next one, we're going to go with 1 for x. So 3 times 1 plus y equals negative 8. That's going to be 3 plus y. So we're going to subtract 3 from negative 8. And so that means y is going to give us negative 11. We have to be careful when we're adding two negative numbers together, or we're subtracting a negative, or subtracting a number from a negative. Okay, we have to make sure we calculate that correctly. So when x is 1, y is equal to negative 11. We can keep going. We'll plug in 2. That gives us 3 times 2 plus y is equal to negative 8. That'll give us 6 plus y, which we subtract 6 from both sides. So y is going to be equal to negative 14. And hopefully we can start to see a pattern working here. Okay? We can start to see a pattern. As we increase by 1, okay, we increase by 1 here, we increase by 1 here. One more time. What is happening to our y value? Well, our y value is decreasing by 3. So as we continue to go, we can go all the way essentially to 9 if we would like. I'm going to throw a couple of negative numbers in there. So that way we have some numbers to plot that are outside of quadrant 1. So that way we can kind of see what the whole deal is when we plot these. Okay, so I'm going to go 3, and I'm going to go 4 too, just because. Why not? Who cares? So that's going to give me 3 times 3 plus y equals negative 8. So it's going to be 9, subtract 9 from both sides. And so y is equal to negative 17. Then we have 3 times 4. Yeah, 3 times 4. So that would be 12 plus y is equal to negative 8. Subtract 12 from both sides. And so y is equal to negative 20. Fantastic. Let's fix that so we can see it. Great. So when x equals 4, y equals negative 20. So we got 5 of these taken care of. Now I'm going to go the other direction. As we're filling in a table, we don't technically have to go in order. We can pick any numbers we want to. Again, we have this open graph, or we have this open table to fill in with any value for x that we would like to, as long as we plug it into our equation correctly. Here, I'm going to plug in negative 1, just because. So when I plug in negative 1, so 3 times negative 1 plus y is equal to negative 8. 3 times negative 1 is negative 3 plus y, so I need to add 3 to both sides. So that means y is going to be negative 8 plus 3, which is negative 5. Again, that should make sense. As we went from, if we go to 1, or from 1 down to 0, we decrease x by 1. What happens to our y? Our y gets increased by 3. So when we go from, I know it's kind of a leap to go from 0 all the way down here to negative 1, but on a graph it's simply just 1 point over. So we go from 0 to negative 1. What happens to our y values? We go from negative 8 to negative 5, an increase of 3. So as we continue these, negative 2, so 3 times negative 2 plus y equals negative 8, so that's going to give me 6 plus y, or rather negative 6 plus y, add 6 to both sides, and y is equal to negative 2. That should make sense. When we go negative 3, so 3 times negative 3 is negative 9, plus y equals negative 8. Add 9 to both sides, and that gives us y is equal to positive 1. Negative 4, and so we're going to increase by 3, we decrease this by 1, so then we're going to increase that by 3, so that's going to give us a positive 4. Fantastic. That's 3 times negative 4 plus y equals negative 8. And I know this is kind of messy, I know this is kind of, I'm just kind of jotting all this down, but this is a very quick calculation that we can do. All right. Again, it's not very difficult. If you have a calculator, punch it in really quickly. Again, what we're looking to do is plug in x values and find what their y values are. The reason for that, the reason that we are choosing our x values and we're not choosing our y values is because of the different types of variables. If you think back to science class, you have 2 different types of variables. You've got independent variables and dependent variables. What's the difference? Well, one of them is one that you change. That's something like time. We've said before multiple times, time is your x value. Time is something that always changes. You only have a second, and then the time changes. And so when you're measuring things that change, that's going to be something that is your x value. It's what we are changing, and that is your independent variable. Over here, your y value is your dependent variable. When we change our x value, obviously our y value changes. And so the exact same thing could be possible if we were to take negative 8 and plug it into our equation for y, and then solve for x. It's going to work both ways, but the way that we put this together originally is by plugging in x values into our table, into our linear equation, and then finding your y values, because those are your dependent variables. Those are what are going to change in relation to the change in x. So when x changes by a certain amount, your y also changes by a certain amount. And it's going to be the same amount based on, essentially, what your equation is. So, let's pick one that's kind of off the wall. Let's just go with 10. Just guys. Who cares? 3 times 10 is 30, so 30 plus y is equal to negative 8. Subtract 30 from both sides. And so 10 is going to give us a value of negative 22 for y. Again, it's okay that these don't go in ascending or descending order. It's okay. We could flip these around in any order we want to, just as long as we also move the corresponding y values correctly as well. All right? That part doesn't really necessarily matter. The only thing that matters is that we, for whatever the x value is, we plug it into our equation correctly. So, now we need to graph this. So, go ahead and take your graph paper and your straight edge. But before we do that, getting ahead of myself, let's turn these into ordered pairs. So our x value is 0, our y value is negative 8, x value is 1, y value is negative 11, x value is 2, negative 14, 3, negative 17, 4, negative 20, negative 1, negative 5, negative 2, negative 2, negative 3, 1, negative 4, 4, and 10, negative 22. Slide that up a little bit. So these are all of our ordered pairs that we're going to then take each and every single one of these ordered pairs and put them on a point, as a point, on our coordinate plane. We got to make our coordinate plane first, though. That's what you need your graph paper and your straight edge for. Okay? Your straight edge really is just to create your coordinate plane, to create your two number lines. Okay? To create a coordinate plane, you need a vertical and a horizontal number line. So let's go ahead and make that. Luckily for us, we've got lots of points. We've got lots of potential dots here. So let's go. We're going to need to actually go more down than we are up. And that's okay. Okay? As we can see, I've got a coordinate plane. Wonderful. Where we meet in the middle here, for those of you who remember from last year, this is called your origin. Your coordinates of your origin are 0, 0. Pretty straightforward. This is where you start. This is where you begin when you go to place values on a coordinate plane. So you start always with every point at 0. From there, we're going to take our coordinates, we're going to take our ordered pairs, and we're just going to place them on our coordinate plane. We're just going to go up, up, put our dot. Very simple. First one is 0, negative 8. So 0, the first number is always your horizontal value. Okay, so if it goes from 0, and you think of it like a number line, here's 0. From one side is your negative values, on the other side is your positive values. 0, though, is neither. Right there in the middle at the origin. But we do need to go down to negative 8. And the reason we go down is because our y value is dealing with our vertical axis. So we go down 1, 2, 3, 4, 5, 6, 7, 8. So here is our first point. My line was off a little bit, so that, of course, is a bummer, but we're going to make the most of it. The next one was 1, negative 11. So that means I go one space to the right, because this is going to be a positive x value, and positive values are to the right of 0. So positive 1 to the right, and then I have to go down 3. So I'm going down 3, 1, 2, 3. So 1, 2, 3. Okay? 1, negative 11. Then the next one, I go 2, negative 14. 1, 2, 3. The next one, I go 3, negative 17. So 1 to the right, down 1, 2, 3. 1, 2. Sorry, these boxes are a little bit smaller than the ones I'm used to. It's okay. And we got one more going this direction. One more to the right, down 1, 2, 3 for 4, negative 20. Okay, so I'm going to label that one just because this one's going to be all the way down here. Realize I just made a mistake in my equation. I put 10, negative 22. Didn't do that right. It's negative 8 minus 30. See, it happens to everybody. Quick calculations, not paying attention. Look what happens. It's not negative 22. It's negative 38. Negative 8 minus 30. Hopefully you all caught that before I did. Negative 38, so it's going to be a ways down there. It's okay. No big deal. So, negative 4, or we got 4, negative 20. Now we're going the opposite direction with our negative x values. So we go back to our origin, and now we're going to go to the left one for negative 1, and then our point at negative 1x is a negative 5y. So we'll go down 1, 2, 3, 4, 5. We go 1 to the left, and so that means we're going to be going up 3. 1, 2, 3. Negative 2, positive 2. We go 1 to the left, and we go up 3. 1, 2, 3. Positive 3, 1. Or negative 3, positive 1. One more. We go 1 to the left, we go up 1, 2, 3. Negative 4, positive 4. Okay? And so, let's name that one as well. Negative 4, positive 4. And so when we have this, let's put the last one on too. 10, so this is 4, so we go 5, 6, 7, 8, 9, 10. And then we have to go down, what, 18 from the last one? But this one might not even be on the paper. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yeah, it's going to be like way down here. Okay, 10, negative 18. It's going to be way down here. Okay? And that's okay. We don't have to put that one on. It's not going to fit. It's not going to, not 10, negative 38. It's not going to be the end of the world. Okay? We can just use the 9 points that we have. And so when we are looking at the 9 points that we do have, what do we notice about them? Hopefully we can see the shape that is being created. Hopefully we can see that we are going in a line. Hopefully we can see that all of our points are going to line up to create a nice straight line. Now it's not horizontal, it's not vertical, and that's okay. As long as there's no like weird bumps and our points aren't way out of whack somewhere, that's going to tell us that we have a line, which means we have a true set of solutions. So when we're taking a look at our assignment later on and they ask you, is this set of points a potential set of solutions for this given equation, what you essentially have to do is you have to pick some points and test them. See, pick a point and say, well, if I plug this number in for x, is it going to give me the number that is corresponding with the y value? If it does, fantastic, then it's a potential point. If it doesn't, then it's not. But when you put all of the points that are part of your solution system together, it should create a line. So if you have something that doesn't create a line, then you can't have then those can't be part of your solution system for that equation. That can't be part of your table. That can't be part of your graph. Okay? So we need to keep that in mind. I know this has been a long one. Hopefully it's made some sense. I do need to show you one other thing. Oop, wrong button. Hopefully this is picking up all this. This is something called a Desmos graph system. Okay? So what you can do is you can take your points and plug them straight into here. So just like ordered pairs. So if I go negative 4, comma 4, close my parentheses, boom, there it shows up. So let's see if I hit enter from here. If I hit enter and let's hit another one, let's go positive 4, and then my x value is, or my y value is what, negative 20? Close parentheses. Gotta zoom out a little bit. Zoom out a little bit. Here's my other point. Okay? You can put your points even without graph paper. You can put your points up here onto the Desmos system and plug them in just like this to see if you get a straight line or not. Hopefully you could see all that. If not, then that's fine. I'll show you on Desmos later on. Okay. Hopefully you have paid attention. Hopefully you have followed along and can follow along and can at least take a stab at your assignment and some of this later classwork, like the one on the next page on page 136, question number 2. Hopefully you can try that on your own. Okay. In the meantime, email me if you have any questions. Adios.